Welcome back to Pleopod, the podcast that demystifies the cutting edge of technology for software builders and curious tech listeners. I'm Armin.
And I'm Maya. Today, we're diving deep into a problem that's becoming increasingly apparent as AI agents move from experimental labs into the complex world of enterprise workflows: reliability.
Absolutely, Maya. We're hearing a lot about autonomous AI agents, systems designed to perform tasks with minimal human oversight. They promise incredible efficiency gains, automating everything from customer service to complex data analysis. But the reality on the ground in many long-running enterprise processes is proving to be far more challenging.
It's like the hype outpaced the engineering, wouldn't you say? We're seeing a significant reliability crisis. These agents, while powerful, often struggle to perform consistently over extended periods, especially when dealing with multi-step, intricate business processes.
That's a great way to put it. One of the core issues is what's being called the compounding error trap. Think about it. If an AI agent has, say, an 85% success rate on any single step, you might think it's pretty good. But string 10 of those steps together, and its overall success rate plummets. In fact, an agent with an 85% success rate per step will only succeed in reaching its final goal about 20% of the time in a 10-step workflow.
Wow, 20%. That's a massive drop. So a small error at step 1 can completely derail everything that follows. It sounds like a domino effect of failure.
Exactly. And it gets worse. We're seeing issues with context drift. Over long-running workflows, agents can gradually lose accuracy. They might start operating on stale information, misinterpret nuances, or even experience a form of memory corruption. This means the agent isn't really working with the most up-to-date or accurate understanding of the task.
That's particularly worrying for enterprise applications, where the data needs to be precise and current. It's not like a quick chatbot query. These are business-critical operations.
Precisely. And this leads to another fundamental challenge: the probabilistic nature of AI. Unlike traditional deterministic software, where the same input always yields the same output, AI agents are probabilistic. Even with identical inputs, they can produce different outputs. This makes standard software testing methodologies largely ineffective.
So you can't just write a test case and expect it to catch all potential issues, because the behavior itself isn't always predictable. That must be a nightmare for quality assurance.
It is. On top of that, enterprise environments are notoriously complex. Data is often fragmented across siloed systems. An AI agent might need to pull information from 8 or more different sources to be effective, which is the case for roughly 42% of enterprises. This complexity introduces high latency and integration hurdles that frequently lead to system failures.
And then there are the security risks, which I imagine are amplified with autonomous agents, right?
Definitely. The threat surface is significantly different. We're talking about risks like prompt injection, where malicious actors can manipulate an agent's instructions, or unauthorized privilege escalation. These are dangers that extend beyond traditional IT security concerns and can have immediate operational or financial consequences.
That's a crucial point. The research highlights that AI agent hallucinations are more dangerous than those in standard chatbots because these agents can autonomously execute actions. A hallucination in a chatbot might give a wrong answer, but a hallucination in an agent could trigger downstream operational, financial, or regulatory failures.
It's a stark reality, and it explains why Gartner estimates that more than 40% of agentic AI projects will be canceled within the next 2 years, citing costs and insufficient risk controls.
So, with all these challenges, compounding errors, context drift, data fragmentation, security, and the inherent non-determinism, how do organizations even begin to tackle this reliability crisis?
It's not just about tweaking the prompts anymore. A lot of current approaches are insufficient. The industry is starting to look towards more robust architectural solutions. One key concept emerging is the self-healing watchdog architecture.
Self-healing watchdog architecture. That sounds fascinating. What does that entail?
Essentially, it's about building a monitoring system that's aware of the agent's intended behavior and can detect deviations. It's designed to automatically correct errors or revert to a safe state when anomalies are detected. This goes hand in hand with implementing deterministic guardrails, hard limits and rules that the agent cannot break, and real-time observability frameworks to understand exactly what the agent is doing and why.
So instead of just hoping the agent gets it right, you're building a safety net and a constant oversight mechanism around it.
Exactly. And it also means rethinking how we monitor these systems. Traditional tools often look at simple metrics, like an HTTP status code returning 200, which indicates success. But that status code doesn't tell you if the agent's logic was flawed, if it performed the wrong action, or if it hallucinated its way through a process. We need deeper semantic monitoring.
It sounds like building truly reliable autonomous AI agents requires a fundamental shift in architecture and tooling, moving beyond the initial excitement to focus on the practicalities of long-term dependable operation.
Absolutely. Research indicates that a significant majority of enterprise agents, around 68%, execute fewer than 10 steps before requiring human intervention. That's far from the fully autonomous vision. Overcoming this reliability hurdle is key to unlocking the true potential of AI in the enterprise.
It's a complex problem, but one that's clearly getting a lot of attention. Building trust in these systems is paramount.
It is. And as these agents become more integrated into core business functions, that trust will hinge entirely on their reliability and safety. We're seeing a clear need for more resilient, observable, and controllable agentic systems.
Well, this has been an eye-opening discussion on a critical, timely issue. Thank you, Armin.
My pleasure, Maya. And thank you to our listeners for joining us on Pleopod. We'll be back next time with more insights into the technology shaping our future. Until then, stay curious.
Goodbye.
Goodbye.